Hello everyone, welcome to the fifth video lecture on circuit analysis 1. So today we'll see the basic circuit laws, okay? So under this, we'll see the two very important circuit laws, that means Ohm's law and the Kirchhoff's law, okay? So why it is very important laws in electric circuit analysis? Because they are the fundamental laws. That means every circuit analysis will depend on these two laws. Okay, two laws. So when it comes to Ohm's law, it is experimentally relating voltage and current. That means the relation between voltage and current for certain resistive elements. When it comes to Kirchhoff's law, we have two basic laws. That means the Kirchhoff's current law and the Kirchhoff's voltage law. Okay. So based on this, we can determine the voltage across an element or current through an element by applying Ohm's law or Kirchhoff's law. Okay. So when it comes to the first law, that means the Ohm's law, it states that the current I flowing through the resistor is directly proportional to the applied voltage V across the resistor and inversely proportional to the resistance. That means, as you can see here, the relationship between current and voltage. Current is directly proportional to the applied voltage, okay? So the proportionality constant, that means I can be represented by V over R. So the proportionality constant is alpha, which is represented by 1 over R. To mean that when the voltage increases, the current also, or the current pass through the resistor will also be increased. When the voltage reduced, the current pass through the resistor will be reduced. Okay. So that's how voltage and current for certain resistive element will be related. Okay, that's Ohm's law. So under this, we have two extreme possible values for R. That means you know that resistor, it is the opposing force for current flow through the circuit. The opposing force, force that opposes the flow of current through conductive elements. So we have two extreme values for resistor when R is equals to 0, when R approaches 0, and when R approaches to infinite. For this case, the circuit is short circuit. Okay, short circuit. And for this case, the circuit is open circuit. Okay, open circuit. For this case, current is 0. For this case, for short circuit case, voltage is 0. Okay, voltage is 0. So we have these extreme values for resistor. You know, for resistor, that is property of electrical material, and it is given by using Ohm's law. R is given by voltage over current. Okay, so from the Ohm's law, V, it is given by I times R. Okay, I, it is given by V over R, and R is given by V over I. And the other very important point for resistor, that is given by rho L over area. Okay, where L is length of the conductor, and rho, it is resistivity of the conducting material, and this A, it is cross-sectional area of the conductor, cross-sectional area of the conductor, and rho, it is the resistivity of the material. That means different electrical materials will have different resistance value. For example, you can consider copper and aluminum. Okay, So for copper, it has a very low resistive value, and for aluminum, it has high resistive value. So the resistance will be, the resistance for aluminum is greater than the resistance for copper. Okay, so different electrical materials will have different resistive value. So we can determine the resistance using this formula. Okay, so when we see, as we have seen in the previous slide, the open circuit and short circuit, the physical meaning, so it will be determined by the value of R. So the R can be ranged from 0 to infinity. So it's important that we can consider the two extreme possible values. Okay. So for this case, for the first one, as you can see here, we are assuming that there is certain source. There is a certain source here. Okay, supplying source. Okay, so you can consider the resistance is 0. So across the terminal of the resistor, that are the two terminal elements of circuit. So across, since the resistance value is 0, so the voltage will be 0. That's we call it short circuit. Short circuit. So if we apply a source at this terminal, we are making or we are connecting the positive terminal with the negative terminal for this circuit, and we are connecting the neutral with the phase for AC circuit. So an element with R is equal to 0 is, we call it short circuit. So for short circuit, voltage is 0. So the figure shows that the voltage is 0, but the current could be anything. Current can be any value. Rather, the voltage is 0. Okay. Similarly, an element with R is equal to infinite is known as an open circuit. For this case, current is 0. So, but the voltage can be any value. So as you can see here, this one indicates the current is 0 through the voltage. So the voltage could be any value. Okay. So that's how. What does it mean R is equal to 0, and what does it mean R is equal to infinite? The physical meaning. Okay. We know that resistance, it is the opposite force for flow of current. So that is an element denotes its ability to resist the flow of electric current. So it is measured in ohm. So the unit of resistance is ohm. The reciprocal of the resistors is known as conductance and is denoted by G. So the conductance is a measure of how well, okay? It's a measure of how well an element will conduct electric current. Okay? So the unit of conductance, it is mho, okay? Or spelled backward, or the reciprocal of ohm. Okay, or you can use the inverted omega, or Siemens, which is the unit of conductance. Okay, the unit of conductance. So G, it is the reciprocal of resistance. That means 1 over R. Or if you have the conductance at your hand, you can determine the resistance by taking just simply the inverse of conductance. Okay. So Ohm's law can be holds true for the conductance. Okay, we know that voltage it is given by I times R. We know R is 1 over conductance, so we can represent V, which is I over G, or from this we can write G, the conductance, which is I over V, or V, which is equals to current, which is equals to, okay, current, which is equals to voltage times the conductance. So Ohm's law will be holds true if the element has conductance value. Okay, so for this case, for 10 ohm resistance value of a resistor has 0.1 Siemens of conductance value. Just taking the inverse of the resistance value of the resistor. Okay. Let's see a simple example. Let's see a simple example in the circuit shown shown in the figure below. Calculate the current I, the conductance G, and the power P in 3 ways. We have different methods for determination of the power in the circuit, so we'll consider three methods. Okay. So for this case, let's consider we have a simple circuit. We have a simple circuit consisting of one voltage source and one resistor. The value of the resistance value of the resistor is 5 kilo ohm, and the source voltage is 30 volts. So the circuit has two elements. Okay. So let's first determine the current just by applying Ohm's law. Okay. So the current I is given by V over R. V over R. So for our case, the voltage is 30 volt. R is 5 kilo. So the current will be 30 volt over 5 kilo ohm, which is equals to 556. So it should be 6 times 10 raised to minus 3 volt over omega. We know that volt over omega it is 1 ampere. So I can write 6. You know that 10 raised minus 3 it is milli. So milliampere. The current is 6 milliampere. Okay. So conductance, we have given that resistance R is 5 kilo ohm. Okay, 5 kilo ohm. So let's say this one is I, and the second one, that is conductance. Okay, conductance. So we know that conductance is represented by G, which is 1 over R. So R is 5 kilo ohm. So which is 1 over 5 kilo ohm. Okay, 5 kilo ohm. So we have 0.1 over 5 means it is 0.02. 1 over 5 means 0.02. I mean 2. Okay, 1 means 1 divided by 5, which is 0.2. 0.2 times 10 raised minus 3. 10 raised minus 3. Okay, 10 raised minus 3. So we can have the unit, which is 1 over omega, or Siemens, which is 0.2 millisiemens. Okay, Siemens. The third one, we are asked to determine the power. Power, you know that power it is given by voltage times current. So the voltage is 30 volt. Times the current is 6 milliampere. So we can have 30 times 680 millivolt ampere, which is 180 milliwatt. Okay, this is one approach. And the other one is, we know that power that is given by V square over R. So we can have 30 square over R means 5 times 10 raised 3 square. I mean, yeah, which is equals to 900 over 5 times 10 raised 3. So this is v square over r, okay, which is v square over ohm. So you know that which is equals to 180 milliwatt. Okay, 180 milliwatt. And the third one is P, which is equals to I square. Or we can write G times V square. G times V square. So which is 0.2 millisiemens or times 30 square. 30 square. So you have 180 milliwatt. Okay. So using this approach, we can calculate the power, or we can use also P. We can use also P can be used I square times. So we have different approach to calculate the power absorbed by the element. Okay. The second example, which is 100-volt battery, is connected across a resistor and cause a current of 5 milliampere to flow. Okay. You can consider, for example, you can consider battery. Okay, you can consider battery. You can consider battery, which is a positive terminal and a minus terminal or negative terminal. Okay, negative terminal. So we have a resistor. We have a resistor. So the negative terminal to connected to the other. Okay, so this is a battery, which is 100 volt, 100 battery, 100 volt battery. Okay, so the current passing through the resistor is 5 milliampere. 5 milliampere. Okay, 5 milliampere. So we are asked to determine the resistance value. The resistance value. So you can consider resistance as given by voltage over current. Voltage over current. Okay, voltage over current. So the voltage is 100 volt. 100 volt. Okay, 100 volt. The current is 5 milliampere. The current is 5 milliampere. Okay, 5 milliampere. So 5 with 5, 1 with 5, which is 20. Okay, so 20 times 10 raised 3 volt over ampere. You know that volt over ampere, which is omega. So which is 20 times 10 raised 3 omega. You know 10 raised 3 it is kilo, so we can have 20 kilo. We can have 20 kilo. So using this, we can determine the value of the resistor, given that the voltage and the current passes through the resistor, just by applying Ohm's law. So we can determine. If the voltage is now reduced to 25 volt, we have already determined with the same resistance value, okay, this one is, let's consider this is, so with the same resistance value of resistor, okay, resistor, the source, the 100 volt is reduced to 25 volt, okay, 25 volt. So what will be the new value of the current flowing? So for this condition, I should be how much? Okay, so for this case, we have R is 5, which is 20 kilo ohm, and voltage, which is 25 volt. So we are asked the current. We are asked the current pass through the resistor. So just you can apply what? Apply Ohm's law. Okay. So I should be equals to V over R, which is 25 volt over 20 kilo ohm. So which is by 5, which is 4, by 5, which is 5. So 5 over 4 milliampere. So that's how we can determine the current just when the voltage previously from 100 reduced to 25. Okay. The third example is, it says that a lamp has 60 watt power when it is connected to a 120 volt of supply source. So we are asked to determine the resistance of the lamp and what will be the power of the lamp if the voltage is reduced half times. Okay, so let's have the solution. Let's have the solution. Okay, let's have the solution. So for the first case, we have given that power is 60 watt and voltage that is given 120 volt. So we are asked to determine the resistance of the lamp. So the required is okay, R of the lamp. R of the lamp is how much? So we know that power that is given by voltage times current, and current is given by from Ohm's law voltage over R. So P is given by V times, instead of I can use this expression. So V over R, so which is V squared over R. So from this expression, I can write R is given by V squared over power. So we can write, we know the voltage is given 120 volt the whole square over 60 watt. Okay, 60 watt. So 120 volt times 120 volt over 60 watt. Okay, so this will be cancelled by 2. Okay, 2 volt. So we'll have 240 volt times volt over watt. You know that volt over watt is 1 over ampere. Okay, so R is equals to 240 volt times 1 over A. We know that V over ampere or volt over ampere, it is O, which is equals to 240 omega. So this is the second question. The second one, which is what will be the power of the lamp if the voltage is reduced half times. So for this case, we are using the same lamp. So the resistance is constant. So we have R is 240 omega. Voltage, for the second case, voltage is half of 120 because the voltage is reduced by half of the previous one. Half times 121 times 120 volt. So voltage would be 60 volt. So we are asked the power consumption of the lamp for this condition. So P is how much? For this condition. So we know that P is given by V squared over R. So we have 60 volt square over 240 ohm. So P, which is equal to 60 volt times 60 volt over 240 ohm. Okay, 240 ohm. So this will be cancelled. So 1 and this is 4. Okay, 240 divided by 60, it is 4. Okay, 4. So by 4, 1, by 4, 50. So P should be equals to 15 volt times volt over omega. So we know that volt over omega is ampere. So P should be 50 volt times ampere. Okay, so volt ampere, which is equals to watt. So P should be 15 watt. Okay, so that's all about for today. Please share, subscribe, like the YouTube channel so that it will be accessible for the others. Thank you very much.